All right, so over the next 2 weeks, we are going to be talking about supplemental lighting or flash photography. So this will be the first of 2 weeks, and this will be the first recording for this week. Come on, there we go. All right, so supplemental lighting. Basically, remember, the word photograph means writing with light. It comes from the Greek, photos and graphy, which means to write with light. But we don't always have enough light. Like right now, my window is right behind the camera, so there's a lot of light coming in from the window, but yet not enough to really light up my office. The sun's over off to the side here, so I've got lights on, and that is providing enough light for us. Oftentimes that is true. Sometimes on a sunny day you can have your windows open, you don't need any lights on in your room, but oftentimes you do need to have an extra light. So the same is true with cameras. When we're outside, we might be perfectly capable in getting our photos, but when we move inside, we might need to add in that flash photography. The other thing that comes into play here is the fact that while we are taking photos even outside, we might have things that are back in shadows. Say like in a car crash situation, you might have stuff underneath the car. So we end up with situations where we do need additional lighting for a number of different reasons. And so we end up using our electronic flash units. Now, taking a look at the history of flash units, we started off with literally, gunpowder being lit off and creating a bright light. We moved forward into some flash bulbs that were basically one-time use flash bulbs. So you can see the bulb there that has kind of like the tinfoil looking inside of it. That was a one-time use device. Coming down here, we've got the flash bulbs that would rotate, and they were a multi-use bulb, but they could only be used, a couple of times each, and they had to cool down and reset. So what you would have is like 4 light bulbs in here, and every time you took a picture, it would rotate, and another light bulb came into play so that the other 3 could cool down. And after each light bulb was used, like 2 or 3 times, the flash unit was dead. You threw it out. And of course, now we have our modern flashes where it is a reusable light bulb, can be used many, many times, and produces quite a bit of light. Of course, when we start thinking about close-up work, we will need to add in some lights at the ends of our lenses so that the light is directed in at the object. We're not going to get too much into this right now. We'll cover this a little bit later, especially when we start talking about macro photography or close-up photography. We'll get more into providing a good amount of light down inside on those close-up images. One of the things we need to be worried about when we think about using a flash unit is something called the inverse square law. And your book has a couple of different pages of it. There's a bunch of math formulas. Don't get too concerned with all of that. Don't worry. But one thing you need to understand is the further away you get from the flash, the less light you get. And there is an inverse proportion to this. So for every 1 foot of distance you cover, you end up with needing, X number of more light. And so as the flash travels away from the camera, you start to lose that light, and it diminishes very quickly. So kind of a cool example of this, when we look down, say the length of this airplane, what you see here is, like these seats are lit up, and then you go to the next row and they're getting kind of dark, and you go to the next row, they're getting kind of dark, the next row, by the time you get to the end of the plane, the dude's just a shadow. And the lights down here, hitting those seats is really just a shadow. So so every foot we go, we're starting to decrease exponentially that amount of light going out. So we end up with a problem that our flashes either need to have more intensity, but the problem comes there, if we have more intensity, now the front of our picture gets washed out, or we need to add in supplemental lighting. So that becomes kind of a thing that we worry about, is our flash intensity. There's a point where stuff becomes a little too bright, or we start to lose things. And so as we move forward and backward through a large area of an image, maybe we need to start thinking about additional factors to get us more light, whether it's supplemental lighting, whether it's changing our ISO settings, a number of different things like that. So here's again kind of showing a flash intensity where, take a look, you've got this tree's kind of washed out, you've got the street lights which are changing our intensity, and so basically as we start moving away, we lose details, But yet now we have a street light over here that is lighting up this tree for us. So our flash only projected so far, yet we get additional light from something else. Another flash intensity error we get. So when we're at a fire scene, we get surfaces that are damp or surfaces that have become wet. And so we end up again with some flash intensity errors where, we end up with this section of wall here tiling that is a reflective surface, and because it is damp, it becomes just that much worse. One of the other issues we sometimes come up with when we start dealing with reflective surfaces like the pinstriping on squad cars and fire trucks. And so again, we end up with this extra little light being bounced back at the camera, where the light bouncing off the finish of the vehicle and bouncing off everything else here is not so bad, but you can see like the Star of Life back here, even just a little bit of light hitting that is designed to become brighter. It is a reflective surface, so we need to be kind of concerned about some of these things also. Another issue that comes up for us is called synchronization, where our flash is synchronized to shutter speeds, but there are certain shutter speeds that don't always synchronize well with flashes because there's the actual speed of light. Light has a specific speed, and there is a amount of time it takes for the camera to send the message from the CPU when you push the button up to the flash unit to send the flash out, and then amount of time for the light to actually get there, hit that object, and come on back. Now the speed of light's pretty darn fast. It's like really one of the fastest things out there. If you science fiction folks, we know like traveling faster than the speed of light is the only way to get from one planet to another and whatnot. And we as humans can't do that yet. So that's why we're stuck here on Earth and the moon. We can't go much further out. So here's some of the things that we can see with some of our flash sync errors, where we end up with a decent looking image here, and we're at 1/25th of a second. But as our shutter speed starts getting faster, the shutter is actually moving faster than, not necessarily than the speed of light, but it's just the fact that it takes time for light to get somewhere and then come back. So we're looking at a slowdown here, and it takes time too because the shutter is moving, but yet it also takes time for the signal to go from the camera processor to the flash unit, for the flash unit to actually fire off the flash, send that light out, have the light come back. The shutter's already moving. So you can see when we get to 1/1000th of a second, the camera missed the flash. When we're at 1/500th of a second, the camera missed part of the flash. That the shutter's already closing by the time the light came back to the camera. So we get some of our sync errors. And you get some interesting sync errors too when you start holding the camera, vertically versus horizontally. So we end up seeing some things where parts of the image get under or overexposed because we're not holding the camera parallel. Now, when we start introducing extra flashes, some of our cameras have the flashes built in. Some cameras we have to add the flash. So when we start adding in a flash, we're looking at utilizing the accessory shoe, and you can see the little tabs here. Not only do we provide power to the flash unit, but these are some areas where data is transferred back and forth between the flash and the camera. And so with the flash units, what we can start doing is telling the flash how far away our object is, our subject matter is, so that the intensity is aiming for that versus having a subject that is closer to us or further from us. So we start kind of negating some of our inverse square law because we're trying to get something that is a specific distance from us, so the flash is going to go out at a specific intensity. We can also start telling our camera what our apertures are and what our shutter speeds are, so that we begin to minimize some of our sync error. Minimize it. Doesn't necessarily eliminate it, but it minimizes it. Keep in mind, many of our cameras have the built-in flashes. The built-in flashes are very limited in what they can do. So it is what the dedicated external electronic flash units really give us the ability to program those flashes. So our built-in flashes are very convenient, but one of the things that comes into play here is they're not very powerful. One of the huge problems when you start taking pictures of people is the built-in flashes are right at the lens, and so they shoot directly into the eyes of people, so that's where you start getting red eye. And to minimize that, what you want is you want to have the flash coming in at an angle so it's not going straight into the pupils and reflecting straight back out at the camera lens. Some of the other things to reduce red eye, are having the person exposed to a bright light so the pupils constrict before you take a picture of them. You can have people kind of look off to the side a little bit so that your picture is still taking a face-on shot, but their eyes are looking off to the side. That doesn't always look natural. So, but we're not doing portrait photography, so we're not too worried about the red eye stuff. When we start getting in close with macro pictures, the built-in flashes just, they're blocked completely by the lens. You never get any light there, so we need those flashes there at the end of the lenses. One cool thing about some of our built-in flashes, though, we can actually set up other flash units. We don't have to actually mount them to our cameras. We can set them up so that they are triggered by the electronic flash unit, so we can have additional flashes out in a scene, just out of view of the camera, that will fill in additional lights. And those built-in flash units, you know, when you're inside and you have a sunny day like today and windows are open and you have plenty of light coming in, those built-in flashes help, you know, kind of reduce shadows and can fill in, creating highlights when we're indoors or outdoors and we have enough light coming in, but we just need that a little bit more for a shadow spot. All right, I'm going to pause this recording here. We're going to have 2 parts to this week's recording, so you can pick up on part 2 here in just a minute.